Hi, in this video we're going to put a point on a grid in order to complete a shape. Now this skill overall is about something called coordinates, and we're going to learn how to read off coordinates, how we write coordinates, and if we're given a coordinate, how we plot it on a grid. But for now, we just want to kind of get a sense of coordinates on a grid by plotting points. So let's do that. We're told we've got A, B, and C are points on a square grid. And on the grid, we want to mark the point D so that ABCD is a square. So I can drag this point D around, and I've got to put D somewhere on this grid so that the shape ABCD, like this, is a square. Now, for the moment, I'm just kind of going to use my gut to work out where it is, and then we'll see why the point is right later. So I think it's going to be about here. Yep, and then I'm going to submit my answer, and let's see if I'm right. Yes, I am right. Good, great, that is the right answer. So let's go to the next one. Right, so this time ABCD's got to be a rectangle. Now remember, rectangle is a bit like a square, but kind of stretched out. It's still got all right angles, so all the angles in it are 90 degrees, but one side might be a different length to the other. So I think if I put it here, that looks like a rectangle because I can see that AB and DC are the same length. So let's submit that. And again, we'll sort of go into detail why this actually works. Yeah, that was right. Well done, me. And it's sort of explained here, but I'll go into that explanation later. And then finally, this one's the hardest. We need ABCD to be a parallelogram. A parallelogram, remember, is a shape, a four-sided shape where opposite sides are parallel, they go in the same direction, but they're also the same length. So I need BC to be the same length as AD. So I'm going to put it here for now. Yeah, that looks like a parallelogram. I'll explain why later. And then let's just submit that. And yeah, I've got it right. Well done, me. Cool. Now let's kind of go back to my note-taking app, and we're going to see why these shapes are the right shape based on where I put my point. So I put point D here, and we wanted ABCD to be a square. Now, why is it a square? Well, if we look, we can see we've got these right angles. So that's a 90-degree angle. So these are all 90 degrees. You get kind of like the corner of a table, if you like. And we also said with a square, all the sides have to be the same length. So for example, this length here, AB, has to be the same length as DC, for example. And BC has to be the same length as AD. Now, if we look on this grid, can you see that as we go from B to C, so if I start at point B, I want to get to point C, I can go 2 squares to the left, and I'm going to go 1, 2, 3, 4 squares down like that. Now, if I start from point A, I want to do the same route to get to D, if I'm at the right point for D. So if I go 2 squares left again, 2 squares left, and I go 4 squares down, 1, 2, 3, 4, you can see I get to the right point. So you can see this was 2 squares, this was 4 squares, and over here, this was 2 squares, and this is 4 squares. So it's got to be the same in order for D to be in the right point. So however I travel from B to C, I would do the same from A to D. What about the second one with a rectangle? It's the same rule that we have here. So for example, if I'm on the point B and I want to get to the point A, in this particular case, I could go down 1, 2, 3, and then across 1, 2, 3 to get to A. And it's going to be the same getting from C to D. So I go down 1, 2, 3, just like I did before from the point B. And we go 3 squares left, 1, 2, 3. We can see it's the same, so D is in the right space. Okay, the last one, a parallelogram. Let's remember what a parallelogram is. The opposite side, so for example, this side and this side, the opposite sides, they've got to be the same length and they've got to be parallel. Remember, parallel is the same direction. So I'm going to put a little arrow like this to say that they're parallel. They're in the same direction. And they look it, don't they? But it's the same rule again. If I start from, say, the point B, and I look how to get to the point C, you can see I'm going 2 squares left and then 2 squares down. And it's the same from A if I wanted to get to D. So I go 2 squares left and I go 2 squares down. And you can see I get to the right point, D.